Get them stopping it.
Steve, close the door. Thank you. And now, lock it.
Always one of those presentations.
No, it's really not. So I'm going to talk a little bit about Brat VIs. There's no planned clever frameworks. There's no object-oriented clever stuff. It's a really simple concept that I think encourages good practices. So that's why I wanted to talk about it. It will take me 10-15 minutes tops, and hopefully you'll take away with you what I think is a neat idea. So what is a brat? So typically a child that is not controlled by its parents or that uses its behaviour to influence its parents. So they're not my kids, by the way, or my wife. So how can that apply in the LabVIEW world? So a Brat VI, it's not a term that I coined. It was coined by Norman Kirchner years ago, before he joined NI, so probably 10 years ago. But it's basically a sub-VI that is not controlled by its caller or parent, but rather it controls the caller. Okay. So how do we do that? So within a sub-VI, what we do is we obtain a reference to the high-level object of interest. So if I'm a sub-VI, I maybe want to carry out some activity or cause my parent or my caller to carry out some activity. So we can obtain a reference to that parent. We can filter particular items that we may or may not be interested in with regard to that parent. And what it means is that there's no passing of data required. Okay. So on that block diagram here, we've got a couple of code snippets. So this one, we've got the call chain. So if I put this in a sub-VI, we use the call chain primitive to get an array of callers of this sub-VI, and we just take out the first element if we want to talk to the parent, for example. And then we can open a reference to that particular VI. So in that instance, if I put that in a sub-VI, I'll obtain a reference to the parent. So it uses call chain. We can also obtain a reference to a front panel of a VI, just wire in the VI reference to a property node, obtain the front panel property of a VI, and then we can get references to things like controls, decorations, panel objects, things on the block diagram now as well, panes and splitters, things that we might be interested in influencing or controlling. So why would we bother? Well, we can achieve complex operations with little or no wiring. Because our Brat VI is obtaining its own reference to the thing that it's interested in, we can drop it on our block diagram and not have to wire anything to it. If it's interested in communicating with its parent or controlling its parent, it's responsible for obtaining the reference to its parent. So we can use multiple instances of that Brat VI throughout our application, and each one will obtain a reference to its own parent. Okay? So what does that encourage? It encourages modularity. So we might have we'll write a Brat VI that is responsible for one particular activity. So it can be used to encapsulate complexity. Let's say that I've got a tree control on my block diagram, on my front panel, and I want to control the behavior of that tree control. Anybody who's done any programming with tree controls or user interface elements knows you end up with property nodes everywhere. The block diagrams can get unruly, so you start putting it into sub-VIs. How about if we just had a Brat VI that obtains a reference to a tree control in its parent and then determines the behavior of that tree control? Okay. All of that complexity for dealing with the tree control would be encapsulated in a single Brat VI. We don't need to pass a wire to it or anything. It's responsible for getting the references it needs, and then it would define the behavior of that particular control. So it encapsulates complexity in a single location. So it fosters reuse. I can have a VI that defines how tree controls operate throughout my application. wherever they are. And what front panel, doesn't matter, I've got one Brat VI that governs how a tree control visually appears, what the font size is, what the column width is, etc. So it fosters reuse, encapsulates complexity, and they're highly modular. Typical uses, so applying common themes and behaviors across many VIs. So multi-column list boxes. If I've got multi-column list boxes scattered throughout my application, maybe I want them to all use the same font size, the same font style, background color, things like that. I can write a Brat VI that I drop into my parent VI that obtains a reference to a multi-column list box and controls and sets its behavior. Okay, so I've got a reusable component that I can use on all my projects to force consistency of appearance. So applying a common theme and behavior controls, and then reusable code for capturing and handling UI events. So if you've done user interface event programming, you start off with an event structure that's like kind of a third of your screen width, and you think, well, what happens if this happens? The user right-clicks on a multi-column list box, and I want to display a menu, and then when they select a menu item, I want to, and all of a sudden you start expanding and expanding, and it gets bigger and bigger and bigger. Right, I need to start putting this stuff into sub-VIs now. If you start out with the aim of, I'm going to create a Brat VI that will be responsible for all of my UI events. So the Brat VI can register for events that have occurred in its parent as well. So we'll see how we do that. So that's why we might want to do that. How we might want to do it. So this was an example where a Brat VI, a sub-VI that doesn't have any inputs to it and is responsible for controlling its parent, how it might be implemented. So here we've got a VI reference going in. I've just dropped a constant down there just for the ease of explaining this. But we've got a VI reference. We open a reference to its panel. We get a list of all of the controls on its panel, and we register the value change events on that panel. So now our sub-VI is aware of when anything happens to any control on its parent. Okay, so we could put particular behavior in this Brat VI to say, I care when somebody right-clicks on the front panel of the VI, or I care when somebody right-clicks on a control, and we can encapsulate that code and behavior in a single location. Okay, so there's no actual wire being passed into this sub-VI. It just obtains a reference to the thing that it's interested in. So it reduces bloat. So in our main VI, in our parent, we might have an event structure in that. And if we wanted to put an event case for every single thing that we're interested in capturing and handling, then all of a sudden these things, they grow rapidly, and we end up with a list of all these possible events that might occur. Having a Brat VI allows us to encapsulate certain behaviors in certain VIs. So this one, we might just be interested in control interaction. We want to handle when the user interfaces with a control, when the user right-clicks on a multi-column list box or a tree control. So all of that's handled here. We might have another Brat VI for taking care of different things. So that means that our top level, our parent, its event structure, if it has one, is far more straightforward. It's not bloated. We haven't got as many different cases in its event structure. Less wiring, not necessarily a good thing, but I put that down there. It's not a reason to use a Brat VI, but it's potentially a benefit of doing so. Is all of the code is contained within this kind of construct here, where it obtains references to the things it cares about. A more reactive code, potentially, if you have just a single event structure on your top level application, then that's an event structure that's handling lots of things. Hopefully, if you've got long running events, you'll actually delegate those off to a second loop to help with those. But if you haven't, and you've got all of your code contained within the event structure, then the responsiveness of that event structure might be slower. So putting events into Brat VIs to deal with can ultimately lead to a more reactive high-level application. So you might have used a few without realizing that that's what you've used. This is probably one of my favorites, resize front panel to largest decoration. Has anybody used it? Does everybody know about Brat VIs? Can I stop now? So resize front panel to largest decoration. It's a OpenG function available on the Tools Network, and it does just that. It's used for resizing the VI to the largest decoration. So let's have a look. Oh, I just love this projector's resin. So this one. So, you know what? We're developing a VI. It's going to do something, and it's going to display a waveform chart. But actually, as we've been writing this thing, we've got some other intermediate information being displayed, debug information. We care about how many times did a loop run, how many samples, the actual raw data array that was being displayed, did it error, things like that. It looks messy, and then what happens? We come along and we think, right, that's terrible. I need to resize the thing, so we drag it, we resize it, we run it. It didn't quite work as we expected, so we start debugging the thing again. So we make it bigger so that we can see all that intermediate information. So if we actually use that VI resize, it's a Brat VI, we can pass it a reference to the VI that we're interested in if we want. If we don't pass that reference in, it will obtain a reference to its parent. So it's a Brat VI. And in this example here, if I run that thing, to show you, if you've not used this before, if I run the thing, so it resizes the panel to the largest decoration. So I've drawn a box around my chart that I care about, and it resizes to that. When I stop running the thing, it sizes back to what it was originally, because I've got some code in there to restore the window size. So I resize to the largest decoration when I start running, and then one of the last things that I do is I size it back to the size governed by the controls on the block diagram. And that might be nice because I might actually want to see some error information displayed in some of my debug controls. So resize VI is quite a nice one. And I think a lot of you have used it already. Let's have a look at another one. Helping with debugging. So who thinks debugging modal dialog boxes is a pain? You know what it's like? You start running your top-level application and some sub-VI that you wanted to do, you wanted to probe some values of, all of a sudden jumps at the front and you can't click on the damn thing. And it's sat there and it's like, oh great, Control-Alt-Delete, Task Manager, kill that, start again, not make it so that it's no longer modal. So this is a bit of code that I wrote to obtain the call chain, get a reference to the parent, get a reference to the parent's block diagram, and see if execution highlighting has been set. So if I'm debugging and I want to see what's actually happening inside my dialog box, then if my parent's been set to execution highlighting, I'll make the front panel behavior of my modal dialog box be non-modal. It won't spring to the front. It will let me click on other things. If I'm not debugging, I don't have execution highlighting set, then it will be set. The other case of this just has modal written in for the front panel behavior, so it behaves as I intended it to behave as a built application. So, yeah, we've all had this situation where you've got some modal dialog box. There's no toolbar because you set it to be a dialog box. You can't click on anything else. The only option really is to kill the thing. You could also expand this with a diagram disable structure around this, so that once you've built the thing and deployed it and it's running using the runtime engine, your dialog box always is modal. If it's in the development environment, then it behaves like a normal VI with a default front panel behavior. So let's have a look at that. Can I have a whip round for a different projector? Okay, so let's go here. Let's go. So I've got this little thing here that sets the modality of. Is it that bad? So really straightforward. It took me 2 seconds to throw this together just for the demo, but obtains the call chain, obtains a reference to the block diagram of its parent, checks whether its parent is execution highlighting, and then sets the front panel behavior of the dialog box. So if I go and run the caller, and drag it across from one screen to the other, so let's make sure it's not in execution. So if I run that thing, I can't click on anything. It's modal. This thing's set to modal. I can't click on my one behind it to abort it. I want to click the stop menu, but I can't. So I've got no option but to kill that one. If I now go back into the caller, drag it back from my other screen. Sorry, didn't want to do that. Sorry, I can actually use a mouse. Just sorry, folks. Just look like I'm on a block diagram of it. Instrumentation. Sorry. Okay. So this time, if I set execution highlighting for my caller, come back over here, run it again, it calls my sub VI eventually. So it's called my sub VI, but this time it's not modal. I can do things with it. I can stop it. So it changed behavior of the front panel based on the execution highlighting status, and quite easily could put a diagram disable structure around that so that it changed behavior between deployed and development environment projects. So it is a pain if you start dealing with modal dialog boxes too early in the development cycle. It's nice to see what they will look like, but then when you get one effectively orphaned on your desktop, they can be a pain to get rid of. So that's another potential use, helping with debugging. And then control behavior definition. So you've got a top level application, and within this application, you've got several windows that may appear as you're performing different things, and they all have a tree control, or they all have multi-column list boxes on them. You could write a Brat VI to handle the behavior and the appearance of all of those windows and have it centralized in that definition of that behavior in a single location. So let's see what that might look. Well, we'll try and see what that looks like. It could be on any screen by now. Let's get rid of these.
How do Americans spell behaviour?
They didn't have a
Can you tell it's a US
PowerPoint.
PowerPoint? It's a US PowerPoint.
Just put a statement mistakes. Or non-statement mistakes.
Should say how many times I get told I've got the date wrong. So if I go ahead and have a look at this one. So I've put a Brat VI in this one that just detects, let's show you. It just detects very, so all it does is, oh, this is painful, sorry folks, this is painful. Tools, window, block diagram. All this Brat VI does is same thing, obtains call chain, gets its parent reference, gets all of the controls on its parents from panel, and then looks for a multi-column list box. I'm making a big assumption here just for the point of the demo that there will only be one multi-column list box, and I'm registering for the events or the mouse down event on that multi-column list box. But it's a contrived example just to show you that the Brat VI can be aware of what's going on in the parent. So there I'm registering for the mouse down event of the parent's multi-column list box. So let's get rid of that. Go back to here. If I run this thing, I also got it to call a couple of sub VIs in parallel to show how you could do this. So if I now on this, I get this little box that's popped up on the other screen, which is convenient, saying that I mouse down on the main VI. If I OK that, mouse down on that one. The same Brat VI that I'm using in my main, I've also used in sub VI2. And sub VI1. So
I'm sorry,
I've got to.
that you had those nonsense.
I didn't.
Who knows what's going on when you're on the screen?
I'm sorry.
Yeah, there was a presentation at NI Days where he said, you can't do it, just hide it.
Yeah, so in those, let's put that one there as well. So in my sub VI, I'd used I'd used a couple of Brat VIs actually. I'd used the one that resizes the front panel, and I'd also used the. In my sub VI, I'd used the resized front panel to largest decoration, but I've also used my Brat VI to obtain a reference to the multi-column list box, and then it's this Brat VI that recognised I'd right-clicked on or mouse-clicked on the multi-column list box, and it was the Brat VI that dealt with that event, and it was the Brat VI that would provide the behaviour that I want. So I might be right-clicking on a multi-column list box and wanting to display a dialogue or some options to the user. That could be encapsulated within the Brat VI, and then it's the same Brat VI that I would use throughout my architecture whenever I want to handle multi-column list box events, tree control events, for example. The user event here is just so that when I finish running my main application, I stop everything, because this thing's effectively running asynchronously, constantly looking for events that occur with the multi-column list box. So you can use them for some really neat encapsulation of behavior. So all of my multi-column list box behavior is defined in that single Brat VI, and that's used by not only the top level application, but all of these. I don't want no dialog box on my other screen. It did, honestly. It did. So that's a Brat VI. Quite useful, and I think it encourages some good techniques actually. In terms of thinking about encapsulating, I don't want my behavior that handles tree control, for example. I don't want it scattered across my application in different places. I want to handle it all in a central location that encourages encapsulation and it encourages reuse. If you find yourself having to define the column headers of multi-column list boxes and tree controls and things like that, and you're doing it scattered throughout your operation, throughout your architecture, it's a bit of a code smell, and you probably want to encapsulate that all into a single location where you've got a Brat VI that is capable of handling everything, all operations to do with column list boxes, tree controls.
So have you got a Brat VI for each one of those front panels?
Nope, I've got a single Brat VI. So
But it's called 3 times.
it's re-entry. So I effectively have 3 copies of it in memory, each one registered for its parent. So if I put one on one block diagram, one on another block diagram, that one cares about the block diagram it's on. This other one cares about its block diagram that it's been dropped on.
And it just stays running.
Yeah, I just pass in the user event just so that I can stop them. Let me show you the block diagram. So that is the Brat VI. So I have a user event that I pass in so that I can stop it running. But otherwise, all it cares about are the controls on its parent. So wherever I've used it, it deals with its parent and nothing else. So I dropped 3 instances of it down throughout my architecture. Each one looks after its own calling VI.
So if you catch them, yeah, because you don't keep calling it, you don't have to worry about closing the references down. If it was one where you
which references?
No, I mean I do similar, but don't leave it open all the time, and I've got to close.
Well, this one
at the end.
This one, I want it to always be aware and to take action if I interact with the front panel.
You don't need to close it.
It's just, it's interacting and being aware of events on the front panel, but not its own front panel, on its parent's front panel. So that's why it's running continually, and then I just use the user event as a means of stopping it effectively. So my top level architecture fires a user event, and it stops all the brats from running.
If you made a change on one and you wanted to make the same change on the others, would it do that, or would that?
Yeah, because on disk I have a single Brat VI. So on disk I have this one. So let's go.
So if you made
if I make
change the colour on one, would it change the colour on the others?
yes, I'm defining a universal behaviour in a single VI that's then called in multiple locations.
A single campaign for all your entities.
But that was my intended behaviour. That was my intention at the start of this, was to say I want to encapsulate all behaviour to do with tree controls in this one thing, and then I can reuse it throughout my application wherever I've got a tree control.
Likewise, if you pick up on your entity number, like 1, 2, 3, whatever, you could say, right, 1's red, 2's blue, 3's yellow.
Yeah, I could tailor it. So in this Brat VI, for example, one of the things that I could do, I'm registering for the multi-column. What can we do? Let's put down a. We could also, we could define the column header strings, for example. No, I didn't want to do that, did I? I wanted to cast it to a. So, using that reference, if I cast to a more specific class, what I could have done is I could have set the column headers, but that would affect the column headers everywhere where I've used it.
Do that so back then.
Yeah.
In best. So.
Yeah, I could do it in here, so that's where this is where I'm just popping up the dialog box, but I could also set the column header or a cell, but that would affect anywhere where I've used the Brat VI. Okay. I'm just having a central location for defining the behavior of that control, and then I'm using it throughout my application. Rather than having bits of code that deal with tree controls or multi-column list boxes or whatever control it is I'm interested in, rather than having that code scattered throughout my application, it's all contained within a single handler.
I think it works. This is my opinion, and when Norman first presented it, my first opinion was that's a control coupling nightmare. But I think if you use it for setting things, then that's fine. What worries me is the event structure inside doing control.
Take over.
Well, it's a software design issue. Control coupling is when the sub-VI controls and is controlled by other VIs. It makes programs hard to understand.
Sorry, just if you've got an event triggering something inside the Brat, you've also got an event, the same event on the main VI. Does it have a fight?
It's kind of, so the examples you showed, they're great because they're doing something to a screen. So essentially, you're the program wise, you're just doing something to get the front panel, which is a fine thing. What worries me is when you have your events and you're doing stuff
Because of it.
there. One, it's it just seems to me that that's going to make your program very hard to understand.
It's all very well.
Eventually, in your example, it won't, because it's an example. In the real world,
If you're rigorous about it, though, the key point that I said earlier on is it encourages encapsulation. That, to my mind, is far better to have all of the behaviour. Say, for example, a multi-column list box. I'm defining the behaviour in one location. If I then defined it in the main VI's event structure, then yeah, you'd have this issue where who's handling that behaviour. I'm saying don't define it in the main VI, define it in the Brat VI, and then it's contained in one location. You have a Brat for handling one control.
We're talking about effectively another layer of abstraction, because there was big discussions a few years back about detaching your front panel effectively, putting a gap in between your front panel and the actual block diagram.
So let's say you don't take this approach and you want to define that when you right-click on a multi-column list box, you do something, and you have 27 multi-column list boxes in your application. That's 27 locations where you have to define that behavior. 27 opportunities to make a mistake, 27 opportunities to have one that doesn't fit with all of the others for inconsistency. 27 times when you decide, actually, that's not the behavior I want, it's something else I want, then you're defining that in 27 locations. This takes care of that by defining it in one location.
Yeah, and this is where I'm struggling with my argument.
I don't think it'd be too difficult to debug, as long as it keeps one level down from calling BI. If you had this running, if you pass your reference way down in the nest, then it'd be really difficult to understand.
But for similar reasons, I try not to use control references for a very similar reason. And
It goes back to
it's control coupling. You are taking the control of something away from where it should be, and that spatial separation will cause issues in large programs, I think. But what you said there is a very good answer to that comment, because grouping together like behaviours makes your program simpler. So it's it's design. It's not a clear-cut thing, but one of the 7 couplings is control coupling, and control coupling is defined as one VI or one subroutine affecting another subroutine's internals.
Yeah, I think the problem is I can't agree with both really. I think I've seen this used where people have looked at it and gone, "Oh, that's great. I don't need to use fires anymore," and completely coded stuff, and it is a complete nightmare. But the examples that Chris has used,
Exactly.
but that's the same. You can say that to anything you like.
It is. I mean, what I'm trying to encourage with most things now is that people sort of say the trade-off is this. Use that garbage, especially with the education side, is do this, but if you do this, this is going to get hard.
I've just,
But it's just powerful.
I'm just going to do a Greek translation. And it's a good thing to do that, so you've got to change the font.
Yeah.
So if you have English font, that's all right, but then if you're using French, the French accent is all right, work okay in English, but in Greek they go into a different
But from my view,
So
that's not
change
control
that.
coupling, because you're doing an action, you're doing an action on the VI. It's the control coupling is when you're using an event, or you're to go up, or and you're prodding behaviour into the caller.
I've seen it used for switching booleans on top level.
Yeah, that kind of.
but like value signaling type stuff is
So that, there's rules of bad as well as rules of good.
So what's the properties rather than value?
cosmetics.
Well, I mean,
That I wouldn't use for anything more, no disrespect. That I would use for exactly what you've said it's there for. It's basically what colours, what sizes, what fonts. If you start using that to effectively control your indicators and control your boolean switches, etc., you're just going to be stuck.
well, I mean, it shouldn't be black and white. There's no good. It's a design issue, really. If you've got a very complex design solution that is made simpler by doing this, then do it. For Christ's sake, make it simpler, whatever. It doesn't matter. But there is a danger with control coupling, and it's a software danger. It's not a LabVIEW thing. It's not LabVIEW specific, but plenty of different languages park references into little VIs and objects and things that affect other objects and things, and it just turns into a complete programming headache.
I can see this being used totally on the monitoring side, where you look for the way that somebody has pressed buttons and things like that. So if you want to see what a user's actually done to break your code, you do that, and you look for value change in all your controls, and you log it. And and that'll be sat in a Brat on its own. It won't control anything. It will just tell you what's happened.
And the beauty of all these techniques is you'll get a use case one day when you have to use it. I've got a customer that needs that type of thing, and there's no other way around it. You have to do that kind of thing for them.
So the first use that I had for this is that I had a customer who wanted to skin their application. They wanted a theme for the app, but they also wanted to be able to sell it on to other people and apply their own theme to it without redefining the whole application. So I think like tree controls, what glyphs they would use when they were expanded and collapsed, what the font size would be, what the font colour would be, the background, the alternate row colours and multicolour list boxes, things like that. They just wanted to be able to put their own theme across the entire application without they tried it once before, and they basically put all of that code that defined the visuals in several hundred locations that they then had to go and find. And in some, they defined part of the behaviour, but not all of it. And others, they had naked calls to property nodes on the block diagram, which trying to find all of those is just time consuming. So this was a quick way of giving them that behaviour, just defining a theme, visual appearance, and then just applying it in one location. But yeah, I mean, it's like all these things, they can be taken to an absolute extreme where they.
It's a way of testing how much overhead this gives you, because it might work very well, but you might get it wrong, and it might do too much every time you press a button, that it actually slows the whole thing down.
So, although I don't actually state this here, I wouldn't. So the example you gave was what happens if I'm handling a mouse down event for a multi-column list box in my Brat VI. That is the only place I would handle that event. I wouldn't handle it anywhere else.
Yeah.
Just be handled in that one. So there's no additional overhead other than calling a sub VI. So with dynamic events, I'm effectively I'm creating a listener for the event and I'm handling it. So there's no more overhead than there would be registering for the event on the top on the calling.
Yeah.
VI. Just the additional overhead of calling the sub VI.
It's pretty efficient.
It's very good.
These days.
And
It's
actually,
obviously better.
there's a benchmark. It's I did it as part of an NI Days presentation a couple of years ago. But actually, if you put one of these listeners in multiple locations listening for the same event, not that that's a good thing, but if you scatter these things throughout your application, listening for mouse down events on the multi-column list box, they don't actually consume any more memory. You can have 200 of these things scattered throughout your application. They do not increase memory consumption. They only do if you increase the number of places where you handle that event. Okay. And you're only handling it in one location. And I would advise you only handle it in one location.
I think that's a lot of the thing, is the rules that are associated with some of these techniques.
Yeah.
Is they're actually quite hard to and take time to sort of formalise.
Which is the other reason why reuse is really good, because you've got the rules there already.
Yeah, I mean, how many times have you found yourself dropping down a property node for column header strings and then wiring in a string array to set the column headers of multi-column list box? If you found yourself dropping that down in several locations in a VI, then it's asking to be encapsulated. Maybe not in a Brat VI, but it's asking to be encapsulated into something. Every time you need to change it, it's one more opportunity for you to forget and not deal with it. So, I mean, I even take it to extremes where if I drop a string constant on a block diagram, even if it's the first time, put it in a VI. Put the string constant in a VI, because you might be using that several times throughout your application. I just put the string constant in a sub VI, and then I even go to the extreme of putting it on the palette, so that if I then change that constant in future, it's one VI that I need to change.
Good stuff, mate.
Thanks.
Well, we could either finish on time.
Or Steve wants his bit of code right.
Yeah.
I could show you that. So,
I can't do it. I can't even get the right screen to it.
I'll have some speech now. Now, let's see if there's going to be feedback. Right? Let's see if it works.
I'm just there talking about.
Anybody actually still listen?
Yeah, have a bit on. He asked you a question, by the way, boy.
Oh, no,